Hi, Honors Algebra 2 students. Mrs. Fallon, we are on lesson 7.3 in your student journal, so I'm on page 202. So we're kind of taking a shift in this unit of sorts. What we're doing is we're switching from graphing to kind of like operations, all right? So instead of doing like graphing rational equations with like asymptotes and all that kind of stuff, what we're going to do is we're going to start looking at all the different kinds of operations with rational expressions. So and then eventually we're going to get to the part where we're actually going to solve. So that's eventually going to be our goal, and we're going to kind of tie everything together. How does the graphing relate to like the multiplication, the addition, the subtraction, division, and then solving as well. All right, so to kind of get started here, we're on page 202 again, so a rational expression. So first of all, just remember that an expression just means there's no equal sign. So you're not solving for x here. We're eventually going to solve equations, but we're not there yet. And so one of the things I want you to remember about a rational expression, it's a fraction. So remember, it's a ratio or a fraction whose numerator and denominator are non-zero polynomials. So numerator and denominator are non-zero. So the reason why that's important is because hang on one second. If the numerator was 0, let's say, for example, I had 0 over x minus 1. Think about what would happen if I had 0 divided by x minus 1. Remember, this is always going to equal 0, right? 0 divided by anything is always going to equal 0. Likewise, if I had x minus 1 divided by 0, think about kind of what we talked about even with trig. When we divide by 0, this gives me an undefined function. So this is why we have to kind of make that disclaimer that the numerator and denominator are not just polynomials, but are non-zero polynomials, because technically 0 is a polynomial. And so then the next part just says simplified form of a rational expression. What I want you to get out of that is just understand that eventually, and I will demonstrate this, is I want you to simplify your answer down to the lowest possible way, okay? I don't know how else to word that. But basically what I'm looking for here is kind of like your last step would be to simplify your expression. So one of the ways that you can tell is that the numerator and the denominator have no common factors. So that's how you can tell if your expression is in simplified form. Okay, so let's chat a little bit about kind of what we're going to be doing today. So today we're just going to talk about simplifying rational expressions. So you might have seen, and we've done this before, where like if you had, a variable on top and a variable on the bottom, you can cancel each other out. So think about like if I had 5x over 2x, right? I could cancel out my x's and I could say this is just 5 over 2. Well, technically this is a rational expression, right? This is a polynomial over a polynomial. They're both non-zero. So understanding that what we are doing here is just canceling out common factors. X is our common factor, and that's what we're canceling out. Same thing goes if I had numbers, right? If I had 15 over 65, a common factor would be 5, right? So we reduce this by 5. So we factor out a 5, and reduce. Same thing goes if I have a polynomial. So see how the numerator has an x plus 3, the denominator has an x plus 3. As long as they have a common factor, we can go ahead and cancel it out. So let me give you an example of one of the problems you might see. So if I had x squared minus x minus 12 over x squared minus 9. So I'm going to put an equal sign here just because I'm kind of extending on like what does this equal, not that I'm having to equal something else. So in other words, this is not an equation, this is just an expression. I'm just simplifying this expression. Your first rule of thumb is to factor everything. Factor the numerator, factor the denominator. So if I'm factoring the numerator, it's a trinomial. Numbers that multiply to negative 12 but add to negative 1 would give me negative 4 and positive 3. And then this is that difference of two squares, so x minus 3, x plus 3. Once it's in factored form, so you can't cancel something unless it's in factored form. Now that it's in factored form, now you might notice that the x plus 3 and the x plus 3 are a common factor from top to bottom, or numerator to denominator. And so then, if I reduce My final answer then would be x minus 4 over x minus 3, because these two things canceled out. Notice that I did not cancel off this x. This x is part of a binomial, which means that it's kind of a package deal. You can't separate the x from the minus 4. The only way you can cancel something out, I'm going to say this over and over and over again, the only way you can cancel something out is if you factored it out first. So if I could factor out an x from the numerator and factor out an x from the denominator, then those two x's can cancel. Otherwise, I can't do it. So notice here that obviously the numerator and denominator, I can't factor out an x because they don't have a common factor. And so at that stage, you know you are completed because you know that there are no other common factors between my numerator and denominator. Let me give you another example that kind of doesn't involve factoring, actually. So if I had 6x squared y over 3xy cubed. Now, we've done problems like this in the past. So what I'm looking for you to do here is, again, kind of think of numbers, numbers with numbers, letters with letters. So notice that we can't factor any of this. The numerator cannot be factored. There's no common factors between. First of all, it's a monomial, right? You can't really factor anything out of a monomial because it's already kind of in simplest form. So same thing with the denominator. It's a monomial. There's no pluses or minuses to indicate that it's a binomial or trinomial. So the only thing you can do here is reduce. So 6 over 3, we can say, well, we know that 3 goes into 3 once, 3 goes into 6 twice. I can say x and x squared. Well, I know that that reduces, and y cubed. So what I'm going to do is just use my exponent properties and reduce this. So I would get 2 on the top, I would have an x on the top, and then a y squared on the bottom. And so then that's kind of how that reduces. All right, let's take a look at a couple others. So let's turn to page 203, which is just our next page. So we're going to look at a few more properties. Again, this is kind of like what I was telling you here. Notice we have 5x squared, 2xy squared, and then 6xy cubed, 10y. Notice that in this problem here, nothing can be factored, right? So those are all monomials. So what I did here is you could reduce anything you can possibly reduce. So I do mine a little bit different than what they did. So what they did here in Big Ideas in this example is they multiplied everything across the top, multiplied across everything across the bottom. Let me just show you another option. And again, either way is fine. Ultimately, we just need you to get to the right answer here. But if I was going to kind of reduce this, so once you factor, right? In this case, nothing can be factored. But once you factored, anything from the numerator can, any common factor from the numerator can cancel with any common factor from the denominator. So like, for example, this 5 and this 10, right? Those are common factors. So I can go in here once, I can go into here twice. The 2 and the 6. So I like to kind of start with all my numbers and then kind of work my way down. All right, so x. So I have an x on top and an x on bottom. Those are going to cancel. I have 3 y's on the bottom, cancel with 3 y's on the top. So what I was trying to get at here is I like to go ahead and reduce my expression before I multiply across the top and multiply across the bottom. I just find it to be easier. So now that I've reduced everything I could possibly reduce, I'm left with, on the top, I'm left with number-wise, I'm left with a 1 and a 3. And then the only variable I'm left on top is an x squared. On the bottom, looks like all of my variables canceled out, and the only thing I'm left with is 2. So this might be your work for this problem. So notice that we got the same answer. So what they did again is they multiplied across the top, multiplied across the bottom, and then simplified that expression. Or you can kind of, before you multiply, simplify everything ahead of time. Let's talk about division. All right, so we know how to divide fractions. I know we did that little kind of warm up at the beginning of the unit. Remember dividing fractions, flip the guy and multiply. There was a couple other sayings I can't remember you guys telling me, but basically that's kind of what you have to remember to do. So let me show you an example. All right, my first rule of thumb is to factor everything. Okay, so what I like to do is, at this stage, factor everything I can factor. So this 3x minus 9, it's a binomial. I can factor out a 3. The x squared minus 5x, to factor a binomial, factor out a common factor. So in this case, it's x. And this trinomial, I can factor into numbers that multiply together to give me positive 5, but add to negative 8 would be negative 3 and negative 5. So what I do is I factor everything first. And again, that doesn't have to be this exact order, but this is, like I said, this is the way I kind of do it. All right, now let's change it to multiplication. So we're going to flip the guy and multiply. So we keep the first fraction. And again, notice that I'm writing it in factored form. Change this to multiplication. I'm just going to flip this fraction. So I have x minus 3, x minus 5 on top, and I have x and then x minus 5 on the bottom. Now let's reduce. So again, you can multiply across the top now and multiply across the bottom and then reduce, or you can kind of look at this and say, okay, what can I get rid of? I notice from top to bottom, I have a common factor of x minus 5. Since everything is factored, we're just looking for any common factors. X minus 3 and x minus 3 can cancel, and even this x and that x can cancel because they're all been factored out. So as long as everything has been factored, you can cancel. All right, so at that stage then, looks like the only thing I'm left with on top is 11, and the only thing I'm left with on the bottom is 3. And so that would be kind of my last step. That would be it. All right, so what we're going to do next is I have a whole bunch, in this practice, right? So on page 204 is a whole bunch of practice. I'm going to go through a few of these examples, and then I'm going to have you guys kind of pause the video and then try some of these on your own. I think it's a good idea to practice, and I know, some of you may do it and some of you may don't, or some of you may not, but I do think it's a good idea to practice these concepts here because little things are going to come up along the way, and you don't want to wait to the test to kind of, make some basic mistakes that you could correct along the way. All right, let's start with number 1. So this is just simplifying the expression. So notice they're not multiplying or dividing anything. Well, I mean, it's a fraction, but you're not like multiplying it by another fraction or dividing it by another fraction. So let's factor everything first. So I'm going to factor out a 2x squared, and I'm left with x minus 4. And on the denominator, well, I can't really factor anything out, right? It's a monomial already. Now, anything from the top can cancel with anything from the bottom as long as they're common factors. So the 2 and the 6 can cancel to 1/3, and actually the x squareds will just cancel out. So then on the numerator, I'm left with x minus 4 over 3. So the couple questions I know that people have asked in the past is like, do you have to write, like, can you write this in parentheses? And the answer is it doesn't really matter. If you wrote that in parentheses or if you don't, because it's going to be the same answer regardless. All right, so let's chat about number 3. My first step in number 3 is to factor everything. So these are both trinomials on the top and a trinomial on the bottom. So numbers that multiply to positive 4 but add to negative 5 would be negative 4 and negative 1. Again, obviously lots of factoring in this unit. Numbers that multiply to positive 1 but add to negative 2 would be negative 1 and negative 1. Notice that x minus 1's cancel. Now, obviously, I can't cancel one factor with those two, even though they're all the same. It's a 1-for-1 ratio. So one x minus 1 will cancel with another x minus 1. And so I'm left with x minus 4 over x minus 1. And again, remember that those x's don't cancel because we didn't factor out. The only way you can cancel something is if you factor it out. So in numbers 5 through 10, it's really just kind of working on multiplication and division. So in number 5, notice they're all monomials. So there's not really a whole lot we have to do in terms of factoring. So we can either multiply across the top, multiply across the bottom, or start reducing. I'll go ahead and do it a different way this time. So I'm just going to multiply across the top. So if I did that, I would get 3xy squared. If I multiplied across the bottom, I'm going to get 2x squared y squared. And just make sure you kind of follow, make sure you're not skipping anything. Now you can cancel. So my y squareds would cancel. One of my x's would cancel. And then 3 over 2 can't be reduced. So my final answer would be 3 on the numerator, and it looks like 2x on the denominator. Let's try number 7. This one is a division problem. So on this one, it is already factored for you, which is kind of nice. So I'm just going to go ahead. So we obviously can skip that step. So we can go ahead now and just change this to multiplication. going to write that in parentheses just because it's easier, I think, for me to think of them all in parentheses. Okay, so I'm just basically flipping the second fraction is all I'm doing here. That's kind of a hard color to see, so I'll move that one away. All right, so then on this one, if you notice, let's go ahead and cancel anything we might have in common. I see some x minus 6s. I see some x plus 1, x plus 1, and I think that's it. On the numerator, I'm going to have x and x minus 9, and on the denominator, I'm going to have x minus 2. You can write that in parentheses, or you don't have to. It doesn't really matter. Again, we can't cancel anything out of here because even though we have like an x factored out of the numerator, we have no value factored out of the denominator, so we can't cancel. Another common question is, what format do I want you to leave your final answer in? And for me, I would like you to leave your final answer in factored form. So in other words, I don't need you to distribute this back through. It's easier for me. Number one, you have to factor it anyway to see if it can reduce, and I don't need you to do that extra step to verify that, to verify or to go ahead and distribute. I know you guys can distribute. So go ahead and leave it in factored form. I do not need you to expand that out. All right, number 9, same deal, except this one has not been factored for us. So our first step is to factor everything. So I'm going to factor the numerator here. So I'm just going to factor out an x. This denominator has already, it doesn't really factor into anything. Be careful on this one. I like this problem. You've learned other factoring techniques. This is x cubed, I'm going to zoom in a little bit, x cubed plus 8. So remember, this is a sum of 2 perfect cubes. Remember that formula? So in case you forgot, let me write it down here at the bottom. It was if you have like x cubed plus, actually if it was a cubed plus b cubed, right? It factors into a plus b, a squared minus ab plus b squared. Now you have this in if you go back to Unit 4 in your comp books, for those of you who are in honors, you should have these formulas in here. So anyway, this is how you factor a sum of 2 cubes, 2 perfect cubes. So be careful, because that's what this one is. So to factor x cubed plus 8, I'm going to let a equal x and b equal 2. Because remember, you take the cube root of the first term, cube root of the second term, and then all I'm going to do is plug it into this formula. So I would get x plus 2, x squared minus 2x plus 4. And if you remember from what I told you guys back in Unit 4, this trinomial at the end here is not factorable. So don't waste your time trying to factor it. And then, okay, the bottom here, let's go ahead and factor this one. So it's x cubed minus 4x. Looks like I can factor out an x, and I'm left with x squared minus 4. But do you see that that is also a difference of 2 squares? So there's another factoring technique here. So we would go x minus 2, x plus 2. So factor completely, I guess, is the rule of thumb here. Factor completely. All right, let's see what we can cancel. All right, so we have all this stuff, right? So I see an x plus 2 and an x plus 2. X minus 2, x minus 2. And I see an x and an x can cancel. And I think that's it. Remember, this can't be factorable, so I'm going to be left with x squared minus 2x plus 4 over x plus 7. And that's my final expression. All right, what I would like you to do is to go ahead and try 2, 4, 6, 8, and 10. And then pause the video, try those 5 problems, and then unpause, and then you can see the answers. All right, so if you've tried them and you want to see the answers, I'm just going to go through answers. If you don't get the correct answer, one of 2 things. I would like you to bring this question to class so that we can go over it if you can't figure out what you did wrong. Or I guess ask a friend. I'm trying to think of what else we could do. Obviously a lot of you are doing this right now, so try to see what other techniques other people are using. All right, so for number 2, I got a final answer of 5 minus 2x over x. For number 4, I got a final answer of x squared over x minus 8. Oops, sorry about that. For number 6, I got a final answer of x plus y over 7x squared. For number 8, I have an answer of x minus 9 over x minus 1. And for number 10, I have x minus 3 over x minus 1. All right, so hopefully you were successful on that. Like I said, if you aren't, bring them to class. Let's go over them, and we'll see where we're at. All right, bye for now.